We're in southern Spain investigating some of the structural deformation associated with the collision of Africa with Europe. But here in these Cretaceous sediments we see some really quite nice paleo-environmental indicators as well. So most of the sediments are these white marls, so they're muddy limestones, if you like, but you can see at the base of this cliff here just behind me it's much darker, and these are black shales. And during the Cretaceous we had these global anoxic events in the oceans, so the oxygen content of the oceans dropped a lot, which meant that a lot of organic matter actually survived to the ocean floor, and you've got these very carbon rich shales. And this one behind me is the Ocean Anoxic Event 2, OAE 2, which marks one of the boundaries, and it's a global boundary we see in the Cretaceous all the way across Cretaceous sediments around the world. And here, because you have black shales, and often it's a black chert here, we see foraminifera preserved within the cherts in particular, and these are quite important environmental indicators. At the start of these OAEs, the forams are really quite large, like this one here, but by the time you get to the end of the OAEs, they've been so stressed that these creatures aren't really growing very large at all, and they get probably 5 times smaller. So we can see that there's a global stressing, and a stressing all the way through the water column, because these forams are planktonic. They're living in the photic zone right at the top of the ocean, but these are being stressed by the lack of oxygen as well. We don't really know what caused them. Possibly during the Cretaceous there was a lot of volcanic activity on the ocean floor. A lot of fresh ocean ridge was being produced, and maybe all of that volcanic activity caused this deoxygenation of the ocean.